Alrighty, guys. So 5.2b lesson. This first page in the notes is really me giving you notes, okay? And then we'll get into some practice problems after that, okay? Okay, so this first page should be a review, I'm hoping, of 5th or 6th grade, talking about a coordinate plane. We're starting to graph things on a plane that's got an X and a Y axes, okay? All right, so a coordinate plane is formed by the intersection of two number lines. An ordered pair gives the coordinates, which is the location of a point. The first number inside the parentheses is the x coordinate, and the second number is the y coordinate. For example, 2, 3 in parentheses. The 2 is the x coordinate and the 3 is the y coordinate. The x coordinate tells you how many units to move horizontally, which means left or right. And the y coordinate tells you how many units to move vertically, which is up or down. Let me make this a little clearer. Sorry guys, it's a little fuzzy. There we go. All right, the x-axis is the horizontal axis, and the independent, we'll get into that. That might be a new word for you. Independent variable is graphed here. The y-axis is the vertical axis, and the dependent variable is graphed here. The intersection of the x and y axes is called the origin. Its coordinates are 0, 0 in parentheses. The word linear describes a straight line. The x and y axes divide the coordinate plane into 4 quadrants. Okay, these are Roman numerals here, guys, and it's just kind of customary. It's not a Noonan thing. It's just a customary thing to identify these quadrants. So this is Roman numeral 1, this is 2, this is 3, and the V is a 5 with the kind of eye-looking thing next to it means take 1 away. So that's 4. Okay, 1, 2, 3, 4. Okay, and the way that I remember that 1 and 4 are where they are on a clock. Okay, 1 is where 1 is on the clock, 4 is where a 4 is on the clock, and then it's just common sense in that 2 and 3 pop in order, counterclockwise. Okay. All right, so now you're going to practice what we just kind of discussed. Okay, this should again be a review. Okay, what are the x and y coordinates of point A and B? Okay, so here's point A, and if you want to pause me and do these and then check, go for it. Okay, all right, so you start at the origin. 1, 2, 3 is how many we have to go to the right to get to where A is, and then up 1, 2 is the y coordinate. Okay, so the ordered pair that shows that point then would be 3, 2 in parentheses. Okay, point B, starting at the origin, we go left. Remember, we always go left or right first. Okay, we go left, 1, 2. Left 2 would be -2. And then from that, we go up 1, 2, 3, which is a +3. So the ordered pair that shows the location of point B is -2, comma 3. All right, now describing in words how to plot the point 2 comma 4 on the coordinate plane above. Here's how you would do that in words. Starting at the origin or origin, which is at 0, 0, move 2 units right, then from that spot, move 4 units up. Place a dot in that location, That one point is located at 2 comma 4. Sometimes kids think you put 2 dots. Okay, so let me demonstrate what these words just said. Starting at the origin, move 2 units to the right, and then from that point, you're going to move 4 units up. 1, 2, 3, 4. And you're going to put a dot. Okay, that point right there is located at 2 comma 4. Okay. All right, so I want you to pause it if you haven't already and practice putting these points on the graph. Okay, let me go ahead and do this in another color here. Graph and label the points T, 1 comma negative 2. So 1, negative 2, I'm going to label that T. U, negative 3, negative 2. 1, 2, 3, 1, 2, U. V, negative 3, positive 2. 1, 2, 3, 1, 2. That's a V. W is 1, 2. 1, 2. That's W. All right, so that should, I hope, be a review. I'm hoping. If not, it was kind of the bare bones and you're going to need to study the sheet, okay? All right, let's get into our first example. All right, the following table shows the relationship between the amount of cherries in pounds and the cost. Is this a proportional relationship? How do you know? Okay, so let's think about the X and the Y. Okay, so we can go in and get however many pounds of cherries. Okay, that's an independent variable. The cost depends on how many pounds we get. Okay, so this is your X and this is your Y in this case. Okay, so let's think about 1 and 150, $1.50. Okay, wouldn't I need to multiply $1.50 to get that? Let's see if that's true here. Yes, it is. Would this also be times 150? Yes, it is. Would this also be times 150? Yes, it is. Would this? Yes, it is. Because I said yes, it is to all 5 of these, the relationship is proportional. Okay, so I'm going to say yes, since the amount, the X value, is multiplied by the same constant, to get the cost. Cost, which is the Y value. Okay, that sentence that I wrote there, we will be writing 25 times minimum before you take your test. That is the reason every time when you're given a table, if your answer is proportional, why? How do you know? Okay, so you can always say every time since the x value is multiplied by the same constant to get the y value. You can say that every time. Okay, using this context, I put amount and cost in there. Okay, the amount of pounds and cost, but you don't have to do that. You can just say since the x value is multiplied by the same constant to get the y value. That's a generic way to say it every single time, okay? All right, I kind of gave away part B already. It says, is the weight dependent on the cost, or is the cost dependent on the weight? Okay, so definitely the cost depends on how many cherries we're going to buy. Okay, the number of pounds you get is more or less expensive accordingly. All right, now here's the new part, okay? Here's the new part, this graph, okay? It says put the information from the table above on the graph below with the amount of cherries in pounds on the x-axis. So this was the independent variable, and the cost in dollars on the y-axis. This was the dependent variable. Okay, always, always, always. We wrote on the first page, the x-axis, the horizontal axis, is the independent variable, always, always, always. And we wrote on the first page that the y-axis, let me write x and y here just so we can kind of get in the habit of that. The y-axis is always the dependent, okay? All right, and then we're going to draw a straight line through the points if you can. Okay, so the first point is 1, $1.50. So $1.50. The next point is 2 pounds for $3. 2 pounds for $3. The next point is 3 pounds for $4.50. The next point is 4 pounds for $6. And then there's a point 5 pounds for $7.50. Okay, do you think someone can come in and buy 6 pounds of cherries? Absolutely. Do you think someone can come in and buy 10 pounds of cherries? Absolutely. Do you think someone could come in and buy 1.5 pounds of cherries? Absolutely. Okay, when you put your cherry bag on the checkout stand at a grocery store, I can almost guarantee it's not going to be a perfect 2 pounds or 1 pound. Same with an apple. If you want an apple for a snack, okay, it's not going to be a perfect pound or 2 pounds. You're going to pay in the middle of these dots, aren't you? Okay, so let me get a straight edge here. I can draw a straight line through these. Okay, and I'm going to push it down a little bit because I'm hitting the, hang on one sec. I'll push it up in 1 second. I was hitting the base of my computer, so my monitor. All right, so here's the line that I'm drawing through. I'll push it up in 1 second. That says I can buy 0 pounds for $0. Okay, I can buy half a pound for about, I don't know, 70, 75 cents. I can buy a pound for $1.50. Okay, I can buy like 1.25 pound for just under $2. That's what this line says. It says I go on forever. Okay, there may be a grocery store that needs to buy 100 pounds of cherries to sell to its customers. This goes on forever and ever. The arrow on the end says that. Okay, all right. Examine the graph. What conclusions can you make? Okay, so I I connected the points, which made a straight line. Okay, that's called linear. Straight line, we could use the word linear, one word. Linear means straight line, it's a shortcut, kind of a fancier word. Okay, I connected the points, which make a straight line that goes on forever and into the origin. Okay, it's important to understand we're not going to come down here into any negative. Okay, you can't get a negative pound. Okay, we're just focusing on this quadrant 1. You can't get a negative pound and negative dollars. That doesn't make any sense with this situation. Okay, all right, what point on the graph represents the unit rate? Okay, at the point 1, 1.50. It's always where the x value is 1. This is important. This is important to know. Okay, all right, that was our first full example. Let's do a few more. Okay, complete the graph for the table below. Be sure to label your axes with words. Draw a straight line through the points if you can. Okay, number of MP3s and price. Are the number of MP3s and price proportionally related in this situation? How do you know? Okay, let's think about this. This is going to be our X value. That's independent. This is going to be our Y value. All right, that's dependent. Okay, so the price depends on how many MP3s you're getting. All right, so let's think about this. We would need to multiply this by 50 cents to get a buck. That's good. We would need to multiply this 3 by 50 cents to get a $1.50. 4 times 50 cents? Ooh, that is not the same relationship. Okay, so no, there is no constant value that relates the X value, which is the number of MP3s in this case, to the Y value, which is the price in this case. Okay. All right. State the independent and dependent variables. Okay, we already said that the number of MP3s is independent. The price in dollars is the dependent variable. Examine the graph. Well, let's get this information on the graph. All right, so we've got 2 MP3s for $1. Okay, be careful how this is labeled. This is 0.2, 0.4, 0.6, 0.8. $1 would be right here. 3 MP3s for $1.50. Okay, now be careful. $1.20's here, $1.40's here, $1.60's here. So $1.50 is going to be right in between those lines. Be very careful about graphing this and understanding what these lines mean. Okay, 4 is $1.75. Okay, here's $1.60. Here's $1.80. So $1.75 is just under that $1.80 right there. Okay, 5 and $1.90. Okay, I got to get even closer, don't I? Ooh, just just underneath that gray line for $2. 6 and $2. 6 and $2. And then 10, we're going out to 10. Notice that this doesn't go to 7, it goes to 10 and $5. Okay, so $5 is way. Okay, hang on, my duck cam is in the way of my hand here. Okay, label our axes. So remember that our horizontal is always the independent, which is the number of MP3s. This is the independent always. Okay, and I'm going to write in purple on this side so it doesn't blend in with this other pink writing. This is going to be the price in dollars, which is the dependent. All right, I can't make a straight line through this. Heck no. Okay, so I'm not even going to try to. Examine the graph. What conclusions can you make? This is not a straight line. I could have said not linear. Okay, if you wanted to be shorter and sweeter. Okay, let's look at this guy. The following table shows the pounds of meat on a sandwich and the calories in the sandwich. Is this a proportional relationship? How do you know? State the independent and dependent graph, blah, blah, blah. Okay, so the meat in pounds, okay? I could make a sandwich with a very small amount of meat. I could make a sandwich with a lot of meat. So the meat quantity is going to be your independent variable, and the calories that go with it depends on how much meat you put on. Okay, so if I divide 560 by 0.5, if I divide 650 by 1, if I divide 740 by 1.5, do you think I'm going to see the same number here? No, I would not. Okay, so no. And the same answer. Each x is not multiplied by the same constant to get y. Okay, so if you use your calculator and you want to see that, let me pop a couple in here. 560 divided by 0.5. We would need to multiply this by 1,120. This we would need to multiply by 650. Okay, the moment I get two that are different, I can be done. Okay, I know that it's a no. All right, the independent and dependent variables, we just talked about that. So let's get them on this graph. This down here is our x, and that's how much meat we've got. Meat in pounds, this is independent. This is our y. This is going to be our calories, which is dependent. Okay, so our meat in pounds is independent, and our calories is dependent. All right, graph it. I already labeled, let's graph it. So I've got 0.5 and 560. 0.5. 550 is right here. I need to go just a smidge above 550. Okay, 650. 650 is here. 1.5, 740. It's just a smidge underneath there. 830. 830 is going to be right about there. 920, I'm sorry, 2.5, 920. It's just a smidge above. All right, draw a straight line if you can. Well, I can this time. Yep, they're straight. Okay, I drew an arrow tip on the end. Doesn't it make sense that somebody could put 5 pounds of meat on their sandwich if they want to? The calories would be way up here. Okay, but keep in mind this is just a little snapshot. Okay, it's very important to understand you're not going to have any negative calories. You're not going into this quadrant over here at all, nor would you be going over here at all. Okay, so that's really important to understand. Hi. You're not failing, are you? I am, but I'm in the middle of a lesson. Oh, okay. Okay. Examine the graph. What conclusions can you make? Okay, so what I can conclude here, this is a straight line that extends forever, but it does not go into the origin. Okay, so this is a straight line and it doesn't go into 0, 0. All right, there's that one. Next one. The day after Thanksgiving, Games R Us charges an entrance fee of $5 and then $2 per hour for unlimited play. Complete the table. This time we need to fill this out. Okay, we're going to represent the situation by completing that table. Get that arrow out of there. Be sure to label the axes of your graph with words. Draw a straight line through the points if you can. All right, so let's think about this. If I spend 0 time at this place, let's say I've walked in and I've spent 0 time. I'm going to be charged. I'm going to be charged a fee of $5, but I don't have any hours added on. I don't have any hours added on to the $5. Okay, if I'm there for an hour, I would be charged the $5 entrance fee that I'm always charged, plus the $2 for the hour. If I'm there for 2 hours, I'd have $5, and then I'd have to add on $4 to that. If I'm there for 3 hours, I'd have to add on $6 to the $5. Okay, if I'm there for 4 hours, that would be 13, and 5 hours, that would be 15. Huge caution. Do not look at the pattern this way and assume it's proportional. Do not. Okay? That's very important. You always need to look this way. Is there something we can multiply this by to get these values? Can I multiply 0 by anything and get a 5? No way. 1 would need to be multiplied by 7. If I multiply 2 by 7, I don't get 9. This is not proportional. This is not proportional. Okay? All right, so let's go ahead. I'm going to do my dots in purple because I see that my pink ones from the last page kind of seep through. Okay, so 0, 5 is going to be right here in the middle between 4 and 6. 1, 7 is right here. 2, 9 is going to be here. 3, 11 is here. 4, 13. 5, 15. Do you think someone could spend 10 hours in this place? Yes. Okay, I can make a straight line through these dots, and I'm going to extend this line forever with an arrow tip on the end. That says I can spend as many hours as I want. All right. Are the cost and time proportionally related in this situation? Oh, we need to label our axes. Hang on. All right, so our time, this time here is our independent. We can go into this place We can choose to spend no time doing the games. Maybe you're a parent sitting there. They're going to charge you $5 for just walking in the door. Okay. Maybe you are over it after an hour. Maybe you're like, this is the best thing ever. I'm going to be here till they close and I'm going to be here for 6 hours. Okay. So time is independent. You can stay as long as you want. So time in hours, and this is the independent variable. Always. Remember, the independent variable is always on the horizontal, the x-axis. The x-axis. All right, that makes the cost that it will be dependent. This is the cost in dollars, and this is dependent. The cost depends on dependent how long you stay. All right. Is it proportionally related? We already said no. There is no constant value that relates the time to the cost. Okay, remember the time is your X value, but they gave it a T value this time for time. And the cost is your Y value. And they labeled the C for cost for your Y value. Remember that this is your Y axis and this is your X axis. In this case, T and C, okay? All right, state the independent and dependent variables. So time is independent and cost is dependent. Examine the graph. What conclusions can you make? Okay, I'm noticing that this is a straight line. It's linear. That goes on forever. It goes on forever, but doesn't go into 0, 0. Oops, sorry guys, I need to move that up. It's a straight line that's linear. Okay, linear is one word for straight line. So you could say linear goes on forever, but doesn't go into 0, 0. All right, so if we look back at the past several examples that we've done, this picture is not proportional. This picture is not proportional. This picture is not proportional. This picture is proportional. So looking at a graph, is there some commonalities or some differences that we can see that would help us answer these following questions here? Okay, these are going to be very important. Okay, in math, we often make conjectures after observing something. For example, if you observe that your math teacher wore a geeky math t-shirt every day for the first week of school, you might make a conjecture that your math teacher will wear a geeky t-shirt the second week of school. A conjecture is a conclusion based on observations similar to an educated guess that you have to justify. Okay, so number 5, make a conjecture about how to determine if a table of values represents a proportional relationship. Every time, every time, every time. Table, proportional. Here's what you would say. This is what we've said already 5 times. If the X value is multiplied by the same constant to get the Y value, then the relationship is proportional. We've said that every time. If you want to say if the independent variable is multiplied by the same constant to get the dependent variable, then the relationship is proportional. That's another way. Same thing. Okay? Okay, now we're going to make a conjecture on a graph being proportional. Okay? From the first problem we did, all points graphed must form a straight line. Remember, we said that's called linear. If connected, connected, and pass through the origin if extended. That's a key word. Okay, so all the points graph must be linear going into the origin. Okay, so let's look back. We could not find a number that multiplies to these numbers that gets us these numbers. That's the same. It's not proportional. This, we have a straight line, but does it go into the origin? Nope, so it's not proportional. Okay, looking back at this guy. We didn't find the same number that multiplies to get these numbers, not proportional by the table. This is straight, but it does not go into the origin, not proportional by the graph. Oh, let's look at this one. Okay, this one, the table, we could not find a number that multiplies these numbers to get these numbers. That's the same. Nor is this a straight line, and who knows about the origin. Okay. Number one, yes, if we multiply these numbers by $1.50, we get these numbers up here. That's the same number. So the table shows it's proportional. Looking at the graph, linear, into the origin, proportional. Okay. All right, so let me get back to the right page here. So these, know them. These are on your quiz and test for sure. Okay. All right. When two quantities are proportionally related, their unit rate is the same throughout the table or constant. This rate is also called the constant of proportionality or the proportional constant. This has a lot of vocabulary in it. You need to understand it. Okay. All right, so let's go ahead. It says Peter would like to rent Wave Runners for his birthday. He's turning 16. Crazy Rentals was found to be the least expensive, but they only have 8 left to rent the day he was looking to have the party. Each Wave Runner holds 3 people. Complete the table. All right, so if we have 0 Wave Runners, we've got 0 riders. If we rent 1 Wave Runner, whoa, that's a tongue twister for me, we can have 3 riders. If we rent 2, we can have 6 riders. If we rent 3, we can have 9 riders. If we have 15 riders, we better rent 5 Wave Runners. If we have 24, we better rent 8 Wave Runners. Okay, so the independent variable here is the number of Wave Runners rented. This is the independent variable. Okay, so the number of Wave Runners we're able to rent dictates how many people we can have. Number of riders. That's the dependent variable. All right, let's get these on. So 0, 0, 1, 3, 2, 6, 3, 9, 5, 15, and 8, 24. 8, 4. All right. Can we draw a straight line through this? Yes, we can. Is it possible that we might be able to rent 20 wave runners? Sure. Okay, so that means we're going to extend this line with an arrow tip on it that says, I may go off this graph and rent a bunch of wave runners. Okay, we're not concerned with anything in the other quadrants because we're not going to have a negative number of wave runners, nor are we going to have a negative number of riders. We're just focused on this first quadrant. All right, find the ratio of number of riders to number of wave runners for several different ordered pairs in the table. Okay, so we're going to find a ratio, number of riders to the number of runners, wave runners. So 3 to 1, 6 to 2, 9 to 3. So there are several right there. Let me push it up. There are several. Okay, where do you see the unit rate in the table? This is an important question. Okay, you always see it where the x value is 1. Okay, so number of wave runners is 1 and number of riders is 3. All right, describe 0, 0 in the context of the problem. There will be no riders if there are no wave runners. Okay, if we can't rent any wave runners, guess what? We won't be having any riders, right? All right, new part right here, number F, letter F. Write an equation to show the relationship between the number of riders R for n number of wave runners. Okay, do you remember last lesson we had an equation, y equals a number x? Y equals a number x. Okay, well our y in this case is riders, R, and our x in this case is wave runners, which is n. So we just need now to put a number right here. Okay, that number is 3. Okay, if we multiply the number of wave runners by 3, we get the number of riders. Okay, this is very important to be able to do. Okay. Let me pause for just a brief moment here. Sorry, guys, I need to tell somebody that I am running behind for a meeting. Be right there. Sorry. Okay. Get back to this. All right. Are the number of riders and the number of wave runners proportionally related in this situation? Hey, Elise, can you give me 10 minutes? I'm still in the middle of my video.
Sorry.
It's okay. Just need 10 more minutes. I'll meet you right here, okay? Thank you.
Okay.
Thank you. Okay. Are the number of riders and number of wave runners proportionally related in the situation? Justify your answer using your table, graph, and equation. This, you guys, is very important. You will be asked this question on every context that we do. This is very important. Okay, so yes, it's proportional. Yes, it's proportional because aren't we able to multiply these by the same number to get these? And is this linear going into 0, 0? There are your answers. Okay, so let's write those out in words. So each amount of wave runners are multiplied by the same constant to get the number of riders. Okay, do you remember we said in general every time you can say the independent variable is multiplied by the same constant to get the dependent variable? That's what we said, but in this context of wave runners and riders. Okay, that's what we say every time with a table. Okay, now for graph, the points form a straight line and go into the origin. That's all you say. Okay, the points form a straight line into the origin, which is 0, 0. Okay, it needs two things to happen for a graph: straight line, origin. Okay. All right, equation. We haven't talked about that yet. Let's add this part on. Okay. An equation can be written of the form dependent variable equals the constant times the independent variable. Okay, in this case, we had riders equals 3 times n. Okay, it's always the dependent variable, usually y, equals a number times the independent variable, which usually is x. Okay, so you need to know how to justify proportionality with a table, with a graph, with an equation. That's how you do it right there, every time. Okay, state the constant of proportionality. The constant of proportionality is just the number 3, just the number 3. We never write units, no units on constant of proportionality. This is very important. We never have units on a constant of proportionality. All right, state the independent and dependent variables. I feel like we've been over that a couple times already. Okay, the number of wave runners is independent, and the number of riders is dependent. Use the relationship and graph to determine how many wave runners Peter needs to rent if there will be 21 people at his party that all want to ride a wave runner. Let's go back. Let's go back to the table and the graph. Okay, if we want 21 people, it's going to be 7 wave runners. Okay, we want to find out 21 people. Okay, well, let's think about that. To get these numbers to be these numbers, don't we multiply by 3? Okay, if we want these numbers to be these numbers, wouldn't we divide by 3 or multiply by 1/3? So if we multiply that by 1/3, we would have 7. Okay, so that's our answer for this. Okay, another way to find that would be 1 runner to 3 riders. 1/3 runner to 1 rider. Okay, we've been doing that for several lessons. Okay, and then if we multiply this by 21, we would get our 7 runners needed. What is the relationship between the number of riders and the number of wave runners? Number of wave runners gets multiplied by 3 to figure out how many riders. All right, now let's look at this last page. Identify if the following graphs are proportional and justify your reasoning. If proportional, identify the constant of proportionality. Okay, this straight line, yes, does not go through the origin. So no, doesn't go through the origin. So there will not be a constant of proportionality. This one, yes. Straight line through the origin. Okay, the constant of proportionality is where 1 is on the graph. So we have to project above here. This is at 4. It's probably going to be right about 5. So I'm going to put about 5. This guy? No. Not linear. Okay, remember linear means straight line. Okay, so you're going to write none here. This guy? No, not linear. So there is none. There is no constant proportionality. All right, for this scenario, complete the table. Okay, it says the sum of two numbers is 0. Use x and y to represent the two numbers. All right, if this plus this has to be 0, are you good that that has to be a 2? That has to be a 1? That has to be a 0? That's a -1 and that's a -2. And we just need to ask if it's proportional or not. Okay, can we multiply the same number times these to get these? -1's that number, isn't it? Yes. All the x values are multiplied by -1 to get the y values. -1 is the proportional constant. Scooch that up. Okay, so if we multiply this by -1, this by -1, this by -1, and so on, we get our purple numbers. Therefore, it's proportional. Okay. All right, guys, that was a big one. That was the big one of this module for sure. A lot of vocabulary and a lot going on. Thanks, guys.